Venus is the second planet from the Sun and is often referred to as Earth's sister planet due to its similar size, mass, and composition. However, it differs dramatically in terms of its environment. Here are some key facts about Venus. 1. Extreme atmosphere and temperature. Thick atmosphere. Venus has a dense atmosphere composed mostly of carbon dioxide, CO2, with clouds of sulfuric acid, making it incredibly hostile to life as we know it. Runaway greenhouse effect. The thick CO2 atmosphere traps heat, causing surface temperatures to soar to about 465 degrees Celsius, 870 degrees Fahrenheit, hotter than Mercury, even though Mercury is closer to the Sun. Crushing pressure. The atmospheric pressure on Venus is about 90 times greater than Earth's, which is equivalent to being 900 meters, about 3,000 feet, underwater. Retrograde rotation, slow and backward rotation. Venus has an unusual rotation. It rotates very slowly, taking about 243 Earth days to complete one rotation, making its day longer than its year, and it rotates in the opposite direction compared to most planets, including Earth. This is called retrograde rotation. 3. Surface features. Volcanoes and mountains. Venus has many volcanoes, large plains, and mountain ranges. It is believed to have the most volcanoes of any planet in the solar system, although most of them may no longer be active. Impact craters. The surface of Venus is relatively young, geologically speaking, with fewer impact craters compared to other rocky planets, suggesting that volcanic activity may have resurfaced the planet. Match number 4, absence of water. While Earth has abundant liquid water, Venus is incredibly dry. Any water that may have existed in its past likely evaporated due to the extreme heat. Some theories suggest Venus may have once had oceans, but its greenhouse effect caused the planet to lose most of its water early in its history. 5. Phosphine detection and the possibility of life. In 2020, scientists detected traces of phosphine gas in Venus' upper atmosphere. On Earth, phosphine is often associated with biological processes, which sparked interest in the possibility of microbial life in the clouds of Venus. However, this finding is still debated and more research is needed. 6. Space missions to Venus. Venus has been explored by a number of spacecraft, primarily by the Soviet Union's Venera program in the 1960s and 1970s. The Venera 13 probe successfully landed on Venus and transmitted data from the surface before being destroyed by the harsh conditions. NASA's Magellan mission in the early 1990s mapped the planet's surface using radar. More recent missions are planned to further study Venus, such as NASA's Veritas and Da Vinci Plus missions in the coming decade. 7. Brightest object in the night sky. Venus is the third brightest object in Earth's sky, after the Sun and the Moon, earning it the nickname Evening Star, or Morning Star, depending on when it is visible. This brightness is due to its thick clouds reflecting sunlight. 8. Mythology and cultural significance. Venus has been known since ancient times and is named after the Roman goddess of love and beauty. In various cultures, it has been associated with deities of love, beauty, and fertility due to its brightness and regular appearance in the sky. Venus presents a fascinating contrast to Earth, a planet that could have had similar conditions but underwent a drastically different evolutionary path, making it a focal point for understanding planetary atmospheres and climate change. Venus, despite its harsh and extreme environment, continues to fascinate scientists due to its potential past, its geologic activity, and the mysteries still surrounding its atmosphere and surface. Here are some additional aspects that further highlight the uniqueness of Venus. 9. Past habitability in ancient oceans. Was Venus once habitable? There is a growing scientific hypothesis that Venus might have had Earth-like conditions in its distant past. Some models suggest that Venus could have had liquid water on its surface for up to 2 billion years before a runaway greenhouse effect took over. Runaway greenhouse effect. Venus likely experienced a period where it was warm enough to support liquid water. However, increasing solar radiation and the buildup of carbon dioxide in its atmosphere triggered a greenhouse effect that spiraled out of control. The water vapor in the atmosphere would have accelerated this warming, eventually causing the oceans to evaporate. 10. Venus cloud layers and their mysteries. Upper atmosphere. While the surface of Venus is extremely hot and inhospitable, the upper atmosphere, around 50 to 70 kilometers above the surface, is much cooler, with temperatures comparable to Earth's surface temperatures. Some scientists believe that microbial life could potentially exist in these temperate cloud layers, where conditions are less extreme. Unknown UV absorber. Venus has an unexplained phenomenon in its clouds. Something is absorbing ultraviolet UV light. Scientists haven't identified the precise cause of this UV absorption. Some theories suggest that unknown chemicals or even hypothetical microorganisms could be responsible, but this remains one of the many enigmas of Venus's atmosphere. 11. Venus' lack of a magnetic field. No global magnetic field. Unlike Earth, Venus does not have a significant magnetic field. A planet's magnetic field is typically generated by the movement of molten metal in its core. Venus' lack of such a field may indicate that its core is either not convecting or is structured differently from Earth's. Implications for atmosphere. Without a strong magnetic field, Venus is exposed to solar wind, which may have contributed to the stripping away of lighter elements like hydrogen, further depleting its potential for water. 12. Geological activity. Is Venus still active? Volcanism on Venus. While much of the surface of Venus is covered with volcanic plain features, there's ongoing debate about whether Venus is still geologically active. Some evidence, such as thermal anomalies and changes in the atmosphere's sulfur content, suggests there could be active volcanism today. Tesserae terrain. Venus is home to highly deformed, rugged regions called tesserae, which are thought to be among the oldest parts of the planet. These regions are particularly intriguing to geologists because they may hold clues to Venus's tectonic and volcanic history. Craters and resurfacing. Venus has fewer craters than expected, which suggests that the surface is relatively young, possibly around 300 to 600 million years old. This could imply that Venus underwent a massive resurfacing event in its recent geological history. 13. Superrotation of the atmosphere. Atmospheric superrotation. Venus's atmosphere behaves in a unique way. While the planet itself rotates slowly, a Venusian day lasts 243 Earth days, its upper atmosphere moves much faster, completing a full rotation around the planet in just about 4 Earth days. This phenomenon is called superrotation, and it remains an area of active research. Wind speeds. Winds in the upper atmosphere of Venus can reach speeds of up to 360 kilometers per hour, 224 miles per hour, which is astonishing given the slow rotation of the planet. This high-speed circulation plays a critical role in the planet's weather systems. Number 14. Unique polar features. Polar vortex, double-lobed polar vortex. At Venus's poles, there are massive, fast-rotating storm systems known as polar vortices. These vortices are highly dynamic and have a strange double-lobed structure, which changes shape over time. The exact mechanisms driving this peculiar feature are still poorly understood. Cold polar regions. Despite the scorching temperatures at the surface, the polar regions at high altitudes experience some of the coldest conditions on Venus, sometimes dropping to as low as the 173-208 degrees Fahrenheit. 15. Exploration challenges and future missions. Challenges in exploration. The harsh conditions of Venus, its extreme heat, corrosive atmosphere, and crushing pressure make it one of the most difficult planets to explore. Most landers sent to Venus have survived for only a short time. The Soviet Venera landers managed just a few hours. Future missions. There is renewed interest in studying Venus. NASA's upcoming missions, Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, and Veritas, Venus Emissivity, Radioscience, INSAR, Topography and Spectroscopy, aim to explore Venus in the 2030s. Da Vinci Plus will study the composition of Venus's atmosphere, and Veritas will map the surface in high resolution to search for signs of active geology. ESA's Envision. The European Space Agency is also planning a mission called Envision to investigate the planet's geological activity and its atmosphere's interaction with the surface. Number 16. Speculative terraforming of Venus. Terraforming ideas. Some scientists and futurists have speculated about the possibility of terraforming Venus to make it habitable. Concepts include introducing genetically modified organisms to reduce carbon dioxide in the atmosphere, or building floating cities in the cooler cloud layers. However, such endeavors are currently well beyond our technological capabilities and remain in the realm of science fiction. 17. Cultural and historical impact. Historical observations. Venus has been known and observed by civilizations for thousands of years, often linked with the morning and evening skies. The ancient Sumerians associated it with the goddess Inanna, while the Greeks and Romans associated it with Aphrodite and Venus, respectively. In literature and media, Venus has featured prominently in science fiction. In early 20th century works, it was often imagined as a lush, tropical world before we understood its true nature. In modern fiction, Venus is frequently portrayed as an example of a planet ravaged by climate change, or as a future destination for human exploration and terraforming. Venus remains a planet of contrasts, a place of both extreme hostility and profound scientific intrigue. Its past, present, and potential role in understanding planetary climates and atmospheres make it a key target in the ongoing exploration of the solar system.